Namaste student. Today we are going to see limits and continuity part 2. At the end of the session, students, you will be able to evaluate the limits on exponents and logarithmic function. And in this session also, I am going to give some standard results on the limit. And these three limits, you are going to use it for the following example in this session. Limits are, first one, limit x tends to 0 e power x minus 1 whole divided by x. If you are having that format, you can replace the value as a 1. And second one, limit x tends to 0 a power x minus 1 whole divided by x. If you are having a format in this function, you can replace it as log a. And the last one is limit x tends to 0 log of 1 plus x whole divided by x. For this, the result is 1. Okay, let us see on to the example. Example 1. Evaluate the following limits. Limits x tends to 0 e power 5x minus 1 whole divided by x. And this one is in the form of limit x tends to 0 e power x minus 1 whole divided by x. And we know the result of this one is 1. Okay. Now, I'm trying to make this one as in the form of this. That is, here I am having e power x and the power of x, the power of e is in the denominator. But here I am having e power 5x and in the denominator I am having only x. So I am going to multiply and divide by 5 to make this one same. So first I am writing this, that is limit x tends to 0 e power 5x minus 1 whole divided by x. And I am going to multiply by 5 and divide by 5. Now it is in the form of e power x minus 1 whole divided by x. Right? Here e power 5x minus 1 whole divided by 5x. And now I can change this one as 1. So 1 into 5. So 1 into 5 is 5. Your answer is 5. Now, second subdivision. Here they given limit x tends to 0, 2 power x minus 1 whole divided by root of 1 plus x minus 1. In the denominator, I am having a that is root term. So first I need to rationalize this term. I am taking only the function, that is 2 power x minus 1 whole divided by root of 1 plus x minus 1. To rationalize this, I want to multiply and divide by root of 1 plus x plus 1 whole divided by root of 1 plus x plus 1. And in the numerator, I am going to multiply both, that is, there is no change. 2 power x minus 1 of root of 1 plus x plus 1. And in the denominator, I am having in the form of a minus b into a plus b. So I can change it as a square minus b square. Here a is nothing but root of 1 plus x the whole square minus b is nothing but 1. So 1 square. And then the root and this 2 will get cancelled, right? This root and this 2 will get cancelled. In the numerator, there is no change. So 2 power x minus 1 of root of 1 plus x plus 1 whole divided by 1 plus x minus 1. And this plus 1 and this minus 1 will get cancelled. Now, I can write it as 2 power x minus 1 by 2 by x into root of 1 plus x plus 1. Why I am splitting this one now? I am going to split the limit separately for this 2 power x minus 1 divided by x and this one separately, because it's in the form of one result, that is limit x tends to 0 a power x minus 1 by x, and that is nothing but log a. So I'm going to split the limit for this 2. Now I'm taking that is I'm going to take the limit x tends to 0 2 power x minus 1 divided by x into limit x tends to 0 root of 1 plus x plus 1. Yes, obviously this will become log a. Here instead of a I am having 2. So this one become log 2 into, here you can substitute the value of x is equal to 0 over here. So what will happen? Root of 1 plus 0. So root of 1 plus 0 is root 1. Root 1 is nothing but 1. Then 1 plus 1 is 2. Finally, we'll get the answer as 2 log 2. Okay. Now example 2. Evaluate the limit. Here limit x tends to 0 a power x minus 1 whole divided by b power x minus 1, and this one is in the resemblance of limit x tends to 0 a power x minus 1 by x, and we know the result of this one is log a. This is one we used previous sum also. This same thing we used in a previous one, right? Fine. Here I'm going to divide x to the numerator as well as to the denominator. So it will become limit x tends to 0 a power x minus 1 divided by x. Limit x tends to 0 b power x minus 1 divided by x. Now it's in the form of a power x minus 1 divided by x. So we can change it as log a. In the numerator, I am having log a as the result, and in the denominator, instead of a, I am having b. Therefore, this is nothing but log b. Next, second subdivision, limit x tends to 0 e power ax minus e power bx whole divided by x, and it is in the form of limit x tends to 0 e power x minus 1 divided by x, and we know the result of this one is 1. So I am going to change this one in this form, and we have to check that here we are having e power ax, and that two exponentials are there. Okay, for that I am going to add 1 and subtract 1 for this numerator. So limit x tends to 0 e power ax minus e power bx plus 1 minus 1, and in the denominator there is no change, so I written the same. Now make a pair, this e power ax with this minus 1 and e power bx with this 1. So I am getting limit x tends to 0 e power ax minus 1 from this 2, that is from e power bx plus 1, I am going to take minus as a common. So minus of e power bx from plus, if I took minus, then the remaining is minus 1 whole divided by x. Now I am going to split the limit along with the denominator. So limit x tends to 0 e power ax minus 1 by x minus limit x tends to 0 e power bx minus 1 by x, and now it is in this form. So we can change this one as a 1. Obviously I will get 1, but before doing that, check the power. Here e power ax, but here I am having only x, so I need x a. I'm going to multiply by a and then divide by a. The same way here also I need a b. So multiplying by b and dividing by b. Now you can substitute the value as 1. Basically you will get a of 1 minus 1 of b. That is a minus b. Example 3. Evaluate the limit. Here limit x tends to 0. Log of 1 plus ax minus log of 1 minus bx divided by x. And this one is in the form of limit x tends to 0. Log of 1 plus x by x, and we know the result of this one is 1. So I am going to split the denominator as well as limit for this one. So we will get limit x tends to 0 log of 1 plus ax by x, and minus limit x tends to 0 log of 1 minus bx by x. And if you check here 1 plus x, and in the denominator we are having x, but here we are having ax, but denominator is only x. So I need ax. Same way multiply and divide by a. And here I am having minus bx, minus bx. So multiplying by minus b and dividing by minus b. Now you can change this one as 1. So 1 of a minus 1 of, what's the remaining over here? Minus b. Minus b. Then a minus into minus is plus b. And now second subdivision, limit x tends to 1 log x by x minus 1. Here the limit x tends to 1 is given, but if you are having the limit x tends to 0, other than that if you are having means you have to change it the x value. For that I am taking x value is nothing but 1 plus h, and x tends to 1, h tends to 0, and this is in the form of limit x tends to 0 log of 1 plus x by x, and we know the result as 1. Now I am going to replace x is equal to 1 plus h, and I am going to change the limit. So limit h tends to 0 log of, instead of x I can write it as 1 plus h, and in the denominator x is nothing but 1 plus h and minus 1 is there. So plus 1 and minus 1 will get cancelled. Then limit h tends to 0 log of 1 plus h by h, and now it is in this form, so I can change it as 1. Your answer is 1. Now example 4, evaluate the following limit. Here they are given limit x tends to 5. So we need to change the limit is x or h, right? H tends to 0, and then it's in the form of a limit x tends to 0, x tends to 0, a power x minus 1 by x, and the result is log a, right? First I am going to change, that is I am going to make a substitution for a x. X is nothing but x tends to 5 is given, so we can take 5 plus h, and x tends to 5, h tends to 0. Yes, limit, instead of x tends to 5, I am going to write h tends to 0, and 3 power x is there, so 3 power 5 plus h minus 3 power 5 whole divided by x is there. So I am going to write 5 plus h and remaining minus 5. This 5 and this minus 5 will get cancelled. Here the power is in a addition. If the same terms are multiplied, the power is added, right? So I am going to split the power. It will become limit h tends to 0, 3 power 5 into 3 power h minus 3 power 5 whole divided by h. And now I am going to take 3 power 5 as a common, right? And that is the constant. So I am going to bring it front. So 3 power 5 limit h tends to 0, 3 power h minus 1 divided by h. And now it is ready to apply the result. So we will get 3 power 5 into log, instead of a I am having 3. So log 3 is your answer. Now, and this is the last question, limit x tends to a. So here the limit x tends to a is given. So obviously first we have to make the substitution for a x value, and here log is given. The corresponding result is limit x tends to 0 log of 1 plus x by x, and we know the result of this one is 1. So first step, I am going to make the substitution. X is equal to a plus h, where x tends to a and h tends to 0. Make a substitution over there. Yes. Limit h tends to 0 log of, instead of x, I am going to write it as a plus h minus log of a whole divided by, instead of x, a plus h minus a, and this plus a and this minus a will get cancelled. At last we will get limit h tends to 0, and simultaneously see the numerator, log of a plus h minus log a. That is, if log is having a by b, the terms are in a division, then you can write the log in a subtraction. You can write it as log a minus log b. According to that, I am going to write, it's obviously in a subtraction. So I am going to write it in a division. So log of a plus h by a, and in the denominator same h. Now I am having a plus h by a, and this can be written as 1 plus h by a. If you want, you can verify this. 1 plus h by a, while taking an LCM or you are making a simplification, you will get a plus h by a. So limit h tends to 0 log of 1 plus h by a whole divided by h. And here we are having h by a, here we are having only h. So I am going to multiply and divide by 1 by a. So 1 by a by a, and this whole thing has become 1. So 1 of 1 by a. Your answer is 1 by a.